Welcome to Module 10, Basic Router Configuration. This is a hands-on module. After Module 8's Routing Table Theory and Module 9's Address Resolution, this is where students actually configure a router from scratch. Frame it with the on-screen line. A router can't run its leg of the relay race until it's been configured. Objective: implement initial settings on a router and end devices. Preview the topic table. Configuring initial router settings, configuring interfaces, and configuring the default gateway. This module is very command-heavy, so plan for live typing/demo time alongside the slides. 7-step router configuration checklist shown on screen. Set the hostname, secure access, steps 2 to 4, enable secret, console password, VTY password, encrypt stored passwords, add a legal banner, and save the config. This exact sequence mirrors the switch configuration from Module 2, same commands, now on a router instead of a switch. This example topology, R1 connected to a LAN, 192.168.10.0/24, dual stack with IPv6 on one side, and to R2 over a WAN link on the other, leading onward to a remote network, carries through the rest of the module. Same R1/R2 topology style used back in Modules 8 and 9, so it should look familiar. First name the device, and watch the prompt update immediately to reflect the new hostname. A good visual confirmation the command worked. Then secure the 3 access points in order. Privileged EXEC, enable secret, the most important one to lock down, console access, and VTY for remote access. Walk the command block on screen, line by line. With access secured, 3 more steps. Encrypt stored passwords with service password encryption. Add a legal warning banner. Walk the banner MOTD syntax on screen. The hash delimiter marks the message boundaries. And finally, save the config with copy running config, startup config, so none of this is lost on reboot. Interfaces have to be explicitly configured before end devices can reach the router at all. An unconfigured interface is functionally useless, even if physically connected. 3 key commands shown on screen. Description, optional but good practice, up to 240 characters, helps troubleshooting later. IP address, IPv6 address, assigns the address and mask prefix. And no shutdown, activates the interface. Both ends need to be up. Live example enabling both of R1's interfaces. G0/0 over 0 gets a description, dual stack IPv4 IPv6 addressing, and no shutdown. Watch for the %link3updown message confirming it came up. Same process repeats for G0/0 over 1 toward R2. Point out that this message is the router's way of confirming the interface is actually live, not just configured. The fastest way to check interface status across the board. Show IP interface brief and show IPv6 interface brief. Walk the sample output, look for status up and protocol up on the interfaces that should be active. Note VLAN 1 shows administratively down, which is expected and fine on a router that isn't using it. For deeper troubleshooting, show interfaces and show IP interface give far more detail. Speed, duplex, MTU, bandwidth, error counters, and packet statistics. Walk the sample output on screen, pointing out the full duplex/100 megabits per second line, and the input/output error counts as things worth checking when diagnosing a slow or flaky link. Reference table of verification commands, worth having students copy down. Show IP IPv6 interface brief for quick status, show IP IPv6 route for the routing table, show interfaces for statistics across all interfaces, and show IP IPv6 interface for protocol-specific statistics per interface. These will get used constantly in labs going forward. Show IP route and show IPv6 route confirm the router actually learned its directly connected networks. Same C and L codes from Module 8's routing table lesson, now seen on a freshly configured router. Walk the output on screen and have students match each line back to the interfaces just configured in the earlier example. An end device needs a default gateway to reach anything beyond its own local network, but only for that purpose. Key point on screen. If PC1 sends to PC2 on the same LAN, the default gateway is never used at all. Traffic goes straight through the switch. The gateway only comes into play for traffic bound for a different network, shown in the diagram's contrast between same network and different network paths. A Layer 2 switch doesn't strictly need an IP address to function as a switch, but configuring one via an SVI lets an admin manage it remotely, and it also needs its own default gateway to be reachable from another network. Walk the IP default gateway command on screen. Without it, a remote SSH session's reply packets have nowhere to go once they leave the local network. Note IPv6 handles this automatically via router advertisement. No manual config needed. Close the module walking each bullet. The 7-step baseline configuration sequence. Interfaces requiring explicit configuration before anything can reach the router. The brief versus detailed verification commands. Routing table verification confirming directly connected networks. end devices needing a gateway only for remote traffic, and switches needing an SVI plus gateway specifically for remote management, not for basic switching function.